So I'm going to do a review of the circle practice that you guys should have already done. In question 1, I have circle P. They give me a couple arcs. They give me arc QR is 110, arc RS is 94, and an angle QRT is 27. And they want me to find each measure. So the first thing I want to find is angle QTR. QTR is right here. It's an inscribed angle. It's just half the arc. Since the arc's 110, this is 55. The next angle is angle RQS. So RQS is right here. It's another inscribed angle. Since this arc, the intercepted arc is 94, half of 94 is 47. Then I want to find arc TS, which is right here. So I actually really need to find this arc right here. Since this inscribed angle is 27, this arc is twice that, so twice 27 is 54, so that's question D. And now that I know that all these arcs together equal a complete circle, which is 360, so I just did 360 minus 110 minus 94 minus 54, and that gives me the 102. Question E, I want to find angle QSR. So QSR is right here. It's an inscribed angle. It's half of that arc, so half of 110 is 55. And then arc QT is, this angle is 27 and that one's 54. That's the one that I actually already found. So in question 2, that's an inscribed angle. It's half the arc. The angle is 83 and the arc is 9x plus 40. To get rid of that 1/2, I multiply by 2. I multiply the 83 by 2 and I get 166. And then I'm subtracting 40 to get 126, and I'm dividing by 9 to get 14. Question 3 is the same thing. I have an inscribed angle. The inscribed angle is half the arc. So 5x plus 11 equals 1/2 of 16x minus 26. I multiply by 2 again to get rid of the 1/2. So I multiply the left side by 2 and I get 10x plus 22 equals 16x minus 26. I subtract 10x to get 6x. I add 26 to get 48, divide by 6, and x is 8. And anytime if you need to stop the video just to look at something, please do that. On question 4, these are two inscribed angles that have the same intercepted arc. So those angles are equal to each other. So all I did was set them equal to each other and solve for x. And I got x equals 10. They then want me to find arc WX, but I need to find this angle first. So all I did was substitute in. Now that I know x is 10, 6 times 10 minus 7, which is 53. And then the arc is 2 times the inscribed angle, so that arc is 106. On question 5, this is a quadrilateral that's inscribed in a circle. Those opposite angles are supplementary, so they equal 180. So you can see I made a mistake here, but I'm going to take those angles and set them equal to 180. I add the common things. 4x plus 8x is 12x. 7 minus 31 is negative 24 equals 180. I add 24. I divide by 12. I get x is 17. And then I just need to substitute back in. I want to find angle DGF. So all I'm doing is 4 times 17 plus 7, and I get 75. This is the one where I have an angle that's outside of a circle. When I have an angle that's outside of the circle, the angle is 1/2 the difference in the arcs. So 4x plus 15 equals 1/2 of 17x plus 2 minus, and I want to subtract this whole thing. I'm subtracting 7x minus 10, which when I distribute that negative sign is negative 7x plus 10. So I combine these x's together and I get 10x. Combine the 2 and the 10 and I get 12. I subtract 8x to get 2x. I subtract 12 to get 18. X is 9. And I want to find the measure of angle ABC, so all I'm doing is substituting back in. 4 times 9 plus 15 is 51. On the second side, I have question 7. These are two chords that are intersecting. The segments of one chord multiplied equal the segments of the other chord multiplied. So you can see how I'm just using that distributive property. And I get 32x minus 80 equals 14x plus 154. Subtract the 14x to get 18x, and I add 80 to get 234. Number 7, my answer is x equals 13. Number 8, I'm trying to find ML. And you can see I have a right triangle right here. This is a tangent and a radius. So all I'm doing is Pythagorean theorem. A squared plus b squared equals c squared. 9.6 squared plus x squared equals 16 squared. I solve for x. Now when I solve for x, that's my diameter, and they were asking me to find ML, which is just the radius, so that's why I took half of 12.8. 9 is my hat theorem. Remember, if I have two tangents that meet at an external point, they are equal to each other. So all I did was set them equal. 43 minus 2x equals 12x plus 1. I add 2x to this side and I get 14x. I subtract 1 and I get 42. Divide by 14 and I get x equals 3. Again, they want me to substitute because I have to find wy. So 43 minus 2 times 3, and I get 37. Question 10 is I have a secant and a tangent, so I'm doing we. The whole times the external. So for the tangent, the whole thing is 12, and the external, the part sticking out of the circle, is also 12. For the secant, the whole thing is x plus 6, and the external part is x minus 1. This has to, I'm just multiplying this, I'm foiling, and I get x squared plus 6x minus 1x minus 6. And that becomes a trinomial, x squared plus 5x minus 6. Anytime you have to solve a trinomial, you're going to bring everything over to one side. So I subtract the 144, and I get x squared plus 5x minus 150. I then factor this. I'm saying to myself, what numbers multiply to 150 and combine together to give me 5x? And that's going to be a positive 15 and a negative 10. I then set each factor equal to 0. Now this one comes out to be x equals negative 15, and we know the length of something can't be a negative number. So and this one comes out to be x equals 10. Once I know x is 10, then I'm just substituting in because they wanted me to find KL, which was x minus 1, and 10 minus 1 is 9. Number 11, I'm trying to find angle QTS, which is right here. That's an angle that's inside of the circle. So the rule for when an angle is inside of the circle, the angle equals 1/2 the sum of the arcs. So this angle is 1/2 this arc plus this arc. So I'm adding the 80 plus the 154, and that equals 234, and half of 234 is 117. In number 12, I'm trying to find arc JH. Again, that angle's inside the circle, so the angle, which is 55, equals 1/2 the sum of the arcs. Now we know one of the arcs is 76, the other arc is the arc that I'm trying to find, that's my x. So whatever you're trying to find is always going to be your x. To solve this, I need to get rid of the 1/2, and I multiply by 2. So I multiply this side by 2, and that's where the 110 came from. And to solve for x, I'm going to subtract 76, and x is 34. And I want me to find JH, and JH was my x, so I'm done. That's 34. Number 13, this angle right here is 3x plus 41. It looks like an inscribed angle. It's not really, but it does have the same rule that it's 1/2 the arc, so the angle, which is 3x plus 41, equals 1/2 of the arc, which is 11x minus 38. To get rid of the 1/2, I'm multiplying by 2. Now this whole thing gets multiplied by 2, so that's 6x plus 82. And this side I just had the 11x minus 38. I subtract 6x, and that's how I got 5x. And I add 38, and that's how I got 120. I divide by 5, and I get x equals 24. And then angle LMP is 3 times 24 plus 41, and I get 113. And then they wanted me to find angle NMP. So NMP is right here, right next to it. And together those angles add up to a straight line, which is 180. So all I did was 180 minus 113, which is 67. Okay, and I will do a YouTube live to see if there are any questions on this, but I wanted you to see the answers first and for me to explain them first.